So the next problem here is maximum depth of a binary tree. So this is a binary tree. It will only have two nodes at each level, and basically the maximum depth is the number of nodes along the longest path from the root node down the farthest leaf node. So this particular binary tree, the longest is 3. That's the depth. Second one is 2. So we can use DFS, BFS concepts here. So how do you find the maximum depth? Max depth of let's just do better. Depth of binary tree. What's the problem? So I mean this is really just so when we're trying to find the maximum depth of a binary tree, uh, which order should you be using actually? Find maximum depth binary tree. So you should be using yep. So the number of levels, maximum depth of binary tree. So is it in order? Is it like pre-order, or is it post-order? I mean, let's just do the search. Wait, I've forgotten it a little. So which order traversal is needed to find max depth of binary tree? Another binary DFS or BFS can be used. TT 1 plus maximum number of depths at right subtrees. So I mean when they're doing that basically, so let's just find out all traversals in DFS. Okay. So DFS pre-order, is it root node first? Cursively traversed left, cursively traversed right. In order, so pre first root, in order root in the middle, in post order root at the last. So here what we're doing is just we are visiting the node at first itself, which means it is pre-ordering it. So and then left and right. So I mean the concept, the code will be like pretty simple. Like if you're going to use recursion, it would be just say not root. So I'm going to just go directly. Okay, so def is depth root. Okay. If not root, return 0. Otherwise, return 1 plus max def. Oh, okay. Because it's 1 plus actually. So we can use the plus maximum of, because we don't know which one is maximum. Is it going to be left or it's going to be right? So max depth of root left or max depth of root or right. That's it. That's the simplest code, but there is a slightly interesting approach with depth first search. So again, this is DFS with in-order traversal, because we're counting 1 immediately while saving visiting the first node. So if you want to go to the slightly harder route, that would be breadth first search, which I'm going to show here. So 3, 9, 20, 15, 7. So, and again, you should know that the traversal they have given here is also level order traversal 3, 9, 20, and this is null for 9 and 15, 7 for 20. So it's level order traversal they were given as well. So let's go with that. So using BFS, which means level order, go to BFS, it's going to get quite tricky. So we're just going to have to use Q. So def, say, max depth, root. If not root, just return 0. Now let's assign depth to be 0. So Q is dq. dq is function Python. Stands Q. Q can be appended the root. And as far as Q is not empty, depth is 1, because well, at least there's one level here. So now for traversing in the loop of length of Q, well, why we're doing that? Because we're doing level order traversal. Remember that. So we're doing level order traversal. It means that every time you append a node, the length of Q always represents the so Q here always represents the number of things in the current order in the current level. So let's just say I'm going to pop the node Q dot pop left. So remember this function is quite different from list. So list would just have like pop. Additionally, would have pop off some value, but TQ has pop left. So if the node left exists, if and only if node left exists, then append that node left. And if node dot right exists, Q dot append node dot right. So in that case, just return depth first finally over. So why does this work exactly? So let's just say there's 3. So to take the example 9, 20, 15, 7, 9, 20, 15, 7. So at first you had we added like 3 to the queue. So this will be queue. So queue. That's queue. So we have added 3. And then we check if 9 or 20 exists. So okay, so and then so in the length of range of this thing, which is 1, just pop it. So pop and get the node of it. So node would be 3. And then for 3, we check if it has 9 and 20. So again, now since this has been popped already, it means that it is gone. So now 9 has been added and then 20 has been added. Okay. And then we go again. So depth is now that was already 1. Now it would be 2. Now we pop 9. Okay. So it will be gone. And node is now 9. We check it has any children. It doesn't have any children. We just skip that. So now the depth is 3. Not yet. So not so fast. So now the range of length has not yet been over. So now we pop 20. And then that would be gone. And then it would come here. Does 20 have its children? Yes. So 15 and 7 would respectively be appended. And then we go done. And we increment the depth to be 3. and we pop 15 and check if it has anything. Doesn't have anything. Then we pop 7, check if it has any children. It doesn't have any children. That's it. Return 3.